Hello. Well, this is the Miss Young on the weekends. Hat, glasses, don't do your hair, and I don't have Miss Boyd. So you guys, sorry, you're gonna have to put up with me. So today, lesson 8.7, day 2, radical functions. How do I write and graph transformed functions? So example 1, use the description to write the square root function g. The parent function, f of x equals the square root of x, is reflected across the x-axis, compressed, there's a key word again, compressed. Remember, it's either stretched or compressed. I got to get a pen here, working. It's compressed vertically by a factor of 1 over 5. Okay, that's very important. And translated down 5 units. So we have reflected, and it's the x-axis. So that means your y's are changing, so the negative is out front. So we're going to start with a g of x right here. G of x is equal to, I know my negative is out front because that's what the reflected means. And compressed, that's the 1/5. The compressed has nothing to do with the negative. The negative is reflected across the x-axis. Now, take that times square root of x. There's nothing else inside under the radical because it's not going right or left. It's only going down 5. So the 5 is out here. And voila, we're done. Let's see if we can get this. We'll get this circle. And I think we're ready for the next one. Example 2. The parent function, f of x equals the square root of x, is reflected across the x-axis, stretched vertically by a factor of 2, 3 units to the right, and translated up 1 unit. So again, this one we are reflecting across the x-axis, stretching this time, not compressing, stretching by a factor of 2. Remember, if it's greater than 1, if the absolute value is greater than 1, that's a stretch. If it's less than 1, that's a compress. And 3 units to the right, we're going 3 to the right, and we're going 1 unit up. Oh, piece of cake. We can do this. So g of x is equal to, well, reflected across the x, there's that negative, stretched 2. There's our square root, x. This time, because we're going to the right 3 units, remember, it's opposite of what you think, so it's going to be a minus 3 under the radical, right or left under the radical, and up 1. And that looks good to me. Just doing a double check. So I don't have Miss Boyd here. Got to make sure I'm not making a mistake. Now, one thing I want to do, I want to go back up to example 1 for a minute. I wanted to go over this graph. Notice the, let's see if I can get here. Here's the original function right here. It is reflected over the x. There, it drops down here. Compressed. So notice this graph is much flatter than this one. Compressed means it's pushing it down towards the x-axis, and it's translated 5 units down. So 1, 2, 3, 4, 5, and there we go. Let's move on. Example 3, we're going to graph the inequality, and now notice in the last example here, what are we doing? Okay, we're writing the transform function. Now what we're going to do is we're graphing the inequality. In the last lesson, I think we graphed equations. Now we're graphing inequalities, so we either need to use a dashed line or a solid line. So if you refresh your memory, if it is like this or this, that would be a, oh boy, a dashed line. And if it would be greater than or equal to and less than or equal to, that is a solid line. So this example, we know we have to have, right away, we know we have to have a dashed line because it's greater than. So to graph, well, you can use a calculator. but I can't demonstrate that on a video right now. So we're gonna graph this by hand. We're gonna create a table, and let's change the color to this color. So we're gonna have our X's. We're gonna pick, how many am I gonna pick? 4 it looks like I'm gonna pick. And we have our Y's. So we're gonna graph, well, the function 2 root x minus 3. And then we're gonna have our final point, which is our X and our Y. All right, here we go. Well, the lowest X can be, just like we did in the last video, is 0, because you can't have a -1 because that's a negative under a radical. So we're going to start with 0. If we plug 0 in for there, we get 2 root 0 minus 3. Well, that's going to be a -3. Now I'm going to go do 1, because the square root of 1 is just 1. 2 root 1 minus 3. Well, 2 times 1 is 2 minus 3 is a -1. And now I'm going to try 4. So notice I'm doing perfect squares. 2 root 4 minus 3. Well, the square root of 4 is 2. 2 times 2 is 4. 4 minus 3 is 1. And 9. So 2 root 9 minus 3. Square root of 9 is 3. 3 times 2 is 6. 6 minus 3 is 3. So our points are going to be 0, -3, 1, -1, 4, and 1. Yikes. Try that. And 9, 3. Okay. Oh, when Miss Boyd did this, she just did it so much better. She did different colors. Oh, well, I didn't. So now we're going to plot these points. 0, -3, over 0, down 1, 2, 3. 1, -1, over 1, down 1. Over 4, 1, 2, 3, 4, up 1. And over 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, up 1, 2, 3. And it's a dashed line. Oh boy, here we go. I don't know, Miss Boyd, I make fun of you. I should never have made fun of you because I'm a little nervous about this. But, oh, well, maybe not. Maybe I'm better than you at this, Miss Boyd, at the dashed lines. So there we go. There is a graph. It's a dashed line. Well, we're not done, and I don't have a highlighter set up on this little creature yet, on this one, because I have a different slate now. But if it says y is greater than, that means that we are going to shade above this dashed line. So here we go. Let's see how I'm going to do here. So we're going to go above, above, above. Okay, everything is shaded above. And notice I'm not going to the left over here because x has to be greater than 0. I have to be over, so it can be down here, but I have to be to the right of the y-axis. Now, if you're ever like, oh, gee, do I shade above? Do I shade below? Well, if you try, let's see, we could try the point. Yeah, I'm going to try the point here. 0, 0. Right there. Let's have that be our test point. That's our test point. If I plug in the point 0, 0 back into the original, I have 0 is greater than 2 times the square root of 0 minus 3. Is 0 greater than 0 minus 3? Is 0 greater than -3? You bet it is. So let's erase this right here because I don't like the way that looks. Oh, jeebers, I don't like that either. All right, we're going to fix this right now. 0, ooh, yikes. Is 0 greater than -3? Yes, it is. So therefore we shaded above and that was the right thing to do. Let's see, I think that is it on this one. We did a test point. So let's go down to example 4. We're going to save example 4 for class, and we're going to save example 5, And we're going to go right to the video questions. So here they are. Use the description to write the square root function g. You can do that. And example 2 is the same thing. All right, we will see you tomorrow.